Namaskar, I am Anand and you are watching Join for Education. Today I am going to answer the questions of sound. This is the 12th chapter of class 9. Let's start the question answer. So, this is the question number 1. How does the sound produced by a vibrating object in a medium reach your ear? Answer of the question and the relevant figure is in this way. Let's see the answer of the question. When a body vibrates, the air in its neighborhood is alternately compressed and rarefied. The compressed air has a higher pressure than surrounding air. It therefore pushes the air particles near it, causing compression to move forward. A rarefaction or low pressure is created at the original place. This compression and rarefaction causes particles in the air to vibrate about their mean position. The energy is carried forward in this vibration. This is how sound travels. So this is the rarefaction and this is the compression and this is the relevant figure of the question number 1. So this one represent compression, rarefaction, compression, rarefaction, and this is the vibrating particle. Hope that there is no problem to understand the answer of this question. Let's see next question of this chapter. Page number 163, question number 1. Explain how sound is produced by your school bell. Answer of this question will be in this way. When the gong strikes the bell, vibrations are produced in the bell which are transmitted through the air to our ears. These vibrations produce sensation of sound in our ears. Hope that there is no problem to understand the answer of this question. Let's see the second question. Why are sound waves called mechanical waves? So the answer of this question is in this way. Sound waves are called mechanical waves because they need a mechanical medium to travel. Let's see question number 3. Suppose you and your friend are on the moon. Will you be able to hear any sound produced by your friend? Answer of this question is very easy. On the moon, sound cannot travel as there is no atmosphere. Sound cannot travel in vacuum, so we will not be able to hear any sound. Let's see next question. This is the question number 1. Which wave's property determines loudness and pitch? So loudness and pitch, loudness is directly proportional to the amplitude of the sound and pitch is directly proportional to the frequency of the sound. Let's see the answer. Loudness is determined by the amplitude of the sound. Greater the amplitude, more will be the loudness. Pitch is determined by the frequency. Higher is the frequency, greater will be the pitch. So let's see the second question. Guess which sound has higher pitch, guitar or car horn? So we know that pitch is directly proportional to the frequency. So guitar has higher frequency than horn. So the answer of this question will be guitar. Let's see the next question. This is the next question of this chapter. What are wavelength, frequency, time period and amplitude of a sound wave? Answer. of this question, wavelength, the distance between two consecutive compressions and rarefaction of a wave is said to be the wavelength. It is generally denoted by Greek letter lambda, and the SI unit of the wavelength is meter. Frequency, one compression and one rarefaction constitutes one vibration. The number of vibration in 1 second is called frequency. Its unit is hertz. Or the number of vibration per second is also known as the frequency. It is generally denoted by small alphabet F or Greek letter nu. Let's see amplitude. When waves are produced, the particle vibrate about their mean position. The particle vibrate about their mean position. The maximum displacement from its mean position of a particle is called its amplitude. It is measured in meter, so the unit of amplitude is meter, and it is generally denoted by a small alphabet A. Let's see the time period. The time taken by two waves to complete one oscillation or one vibration. The time between two consecutive compression or rarefaction is called time period. The SI unit of the time period is second. Let's see the next question. How are wavelength, frequency of a sound wave related to its speed? We know that speed equal to wavelength into frequency. Wavelength is generally denoted by Greek letter lambda and frequency is generally denoted by Greek letter nu. So velocity of the sound equal to lambda into nu. Let's see the question number 3. Calculate the wavelength of a sound wave whose frequency is 220 Hz and the speed is 440 meter per second in a given medium. So first of all, we make a data. From question it is clear that frequency is 220 Hz, velocity is 440 meter per second, and we know that lambda equal to V by F. Now putting the value of V and F, after the cancelled out of the common factor we get here 2. So the wavelength of this sound wave is 2 meter. Hope that there is no problem to understand this numerical solution. Let's see the question number 4 or next question of this exercise or chapter. A person is listening to a tone of 500 Hz sitting at a distance of 440 meters from the source of the sound. What is the time interval between successive compression from the source? So we know that from the question it is clear that nu or f equal to 500 Hz. Therefore we know that time period t equal to 1 by f or nu. So we put here 1 by f, or the value of nu is 500. After the proper calculation we get here to 0.002 second. So this is the successive compression, and hope that there is no problem to understand numerical solution of question number 4. Let's see the next question of this chapter. Distinguish between loudness and intensity of sound. Answer of the question will be in this way: loudness and intensity both depends upon the amplitude of sound. So, but loudness is the psychological response of our ears to a particular frequency. Our ears are more sensitive to some frequency as compared to others. Intensity is the amount of the sound energy passing per second per unit area. It is proportional to the square of the amplitude. Hope that there is no problem to understand the answer of this question, distinction between loudness and intensity. So these two are the most important topic or factor of sound. Let's see the next question of this chapter. So this is the next question. In which of three media, air, water and iron, does sound travel the fastest at a particular temperature? The transmission of sound we considered at 25 degrees Celsius, and 25 degrees Celsius is the room temperature. At the room temperature, sound travel faster in iron and slowest in air. So in solid, fastest, and in gas, lower. So hope that there is no problem to understand the answer of this question. Let's see the next question. An echo returned in 3 seconds. What is the distance of the reflecting surface from the source, given that a speed of sound is 342 meter per second? From question it is clear that echo 3 seconds, velocity of the sound is 342 seconds. Therefore distance d equal to v into t. Now putting the value of v and t after the multiplication, we get here 513 meter. Of that there is no problem to understand the solution of this numerical problem. Let's see next question. So next question is, why are the ceiling of concert halls curved? So the ceiling of concert halls are curved so that after reflection from the surface, sound can reach each and every part of the hall. Hope that there is no problem to understand the answer of this question. Let's see the next question. What is the audible range of average human ear? So it is very easy question. Audible range of the human ear is 20 Hz to 20,000 Hz. Let's see the next question. What is the range of frequency associated with A, infrasound, and B, ultrasound? So infrasound less than 20 Hz, this is not audible to the human ear. Ultrasound greater than 20 Hz, it is also not audible for the human ear. So hope that there is no problem to understand the answer of this question. What is the infrasound? Depends upon the frequency of the sound, and ultrasound also depends upon the frequency of the sound. Greater than 20,000 ultrasound, less than 20 Hz infrasound. Let's see next question. And a submarine emits a sonar pulse which returns from an underwater cliff in 1.02 seconds if the speed of sound in salt water is 1531 meter per second. How far away is the cliff? So here t equal to 1.02 second, b equal to 1531 meter second. Distance, we know that distance equal to velocity into time. Now putting the value of velocity and time after the multiplication, we get here 7 at 0.81 meter. Hope that there is no problem to understand the solution of this numerical problem. And this is the last question of this chapter. And hope that this answer question and solution of the numerical problem will be useful to the students who are studying in class 9. Please do share or circulate this video lecture to other students of class 9 who are in your surrounding. My next video lecture will be related to some more chapters of other classes, or especially class 9 to 12. If you want to get more details about classes, then join to me in my live class in YouTube. Together with I have a WhatsApp group. If you want to get solution of or answer questions of this or any chapter of 9 to 12 in PDF form, then join into my WhatsApp group. I have a blog in the name of anandprajapati.blogspot.com. Please do visit my blog to get a study material of class 9 to 12. I have one Facebook page in the name of Join for Education. Please do visit there. There are study materials of 9 to 12 also available there. So I request to all of you, please do visit my blog anandprajapati.blogspot.com. Visit to my YouTube channel Join for Education. If you write Anand Prajapati in the search box of the YouTube, then you get my channel. Or join to me in my WhatsApp group if you want to get a study material of class 9 to 12 in PDF form. Thank you very much to stay with me till the answer or solution of last question of this chapter. Hope that solution or answer of the questions of this chapter will be useful to all students of class 9 who tune this channel. Once again, I thanks to all of you. Thank you very much.